Black holes, the most mysterious and terrifying objects in the universe. They warp space, distort time, and swallow everything that crosses their path. But what really happens beyond the event horizon? Is it a gateway to another universe, or the ultimate cosmic prison? Scientists have spent decades studying black holes, but even now, we're far from truly understanding what lies beyond the point of no return. Even the most advanced technology we have today can only provide limited insights into the nature of these cosmic giants. Every discovery brings up more questions, and the closer we get to understanding them, the more elusive they become. The deeper we dig, the more baffling the concept of black holes becomes. The more we explore, the more we realize just how much we don't yet know. To understand what lies beyond, we first need to understand what a black hole actually is. A black hole is formed when a massive star collapses under its own gravity, compressing all its mass into an infinitely small point, what physicists call a singularity. Surrounding this singularity is the event horizon, the invisible boundary where the gravitational pull is so strong that not even light can escape. But it's important to understand that this boundary isn't just an ordinary limit, it's a region where all the laws of physics as we know them start to break down. A black hole challenges everything we understand about space and time. These cosmic objects make us rethink everything about our universe, our perception of time, space, and even reality itself. The very fabric of our universe starts to warp and bend when we encounter the forces near a black hole, reminding us that the laws of physics can be altered in ways we couldn't have imagined. Think of a black hole like a whirlpool in space. Imagine a river flowing toward a waterfall. Once you pass a certain point, there's no way to paddle back. The closer you get to the waterfall, the stronger the pull, until you're caught and pulled over the edge. This is similar to the event horizon of a black hole, where the gravitational pull is so powerful that nothing, not even light, can escape. And just like the whirlpool, the closer you get to the black hole's center, the more intense the forces become. The gravitational forces near a black hole are so extreme that they warp the very fabric of space-time itself. The closer you get to the event horizon, the more pronounced these effects become. The warping of space-time is not just a theoretical idea. It has been demonstrated by scientists using precise measurements of light and the movement of stars near black holes. And these observations are only increasing our fascination with these mysterious objects. Space itself starts to behave like a fluid, bending and curving under the immense influence of the black hole. Now, let's dive deeper into the event horizon. This boundary, also called the point of no return, is one of the most intriguing concepts in all of physics. If you were to fall into a black hole, you'd pass this boundary without noticing anything unusual at first. It would feel like you're floating through normal space. But the moment you cross the event horizon, your fate is sealed, and the laws of physics start behaving in ways we can hardly even imagine. Once you're inside, there's no turning back, no escape. The sheer force of gravity would continue to increase as you fall deeper, and soon you would be experiencing some of the most extreme forces in the universe. At this point, all concepts of normal space and time become irrelevant. Everything that was once familiar would seem strange and distorted, as if reality itself was unraveling. It would be as though you were in a dream, a strange, distorted world where nothing is quite as it seems. As you get closer to the singularity at the center of the black hole, the gravitational forces would stretch you out like a piece of spaghetti. This phenomenon is known as spaghettification. The gravity near the singularity is so extreme that it would pull harder on your feet than on your head, stretching your body out into a long, thin strand. And the further you fall, the more this effect intensifies, until your body is stretched beyond recognition. But what does this process actually feel like? Would it be instantaneous, or would it happen over a period of time? We don't know for sure, but many scientists speculate that the experience would be almost like time slowing down, and you'd likely be completely unaware of the end result. Your final moments would be disorienting, filled with intense pressure, distortion, and a breakdown of everything you thought you knew about physics. But one thing we do know for sure is that, at least theoretically, spaghettification would be one of the most intense experiences imaginable. One fascinating aspect of falling into a black hole is that time itself behaves very differently. As you approach the event horizon, time would seem to slow down. If you were watching the universe from inside the black hole, you might see time outside speeding up. so much so that you might witness the entire future of the universe unfold before your eyes. Galaxies might form, evolve, and decay, all in the blink of an eye from your perspective. But time on the outside, for anyone watching you fall in, would appear to slow down as you approach the event horizon. It's a strange concept to grasp, but it shows just how profoundly black holes distort the flow of time. For you, time might seem to stretch out infinitely as you approach the singularity, while from the outside, it would seem like your descent would take an eternity. This is a concept known as time dilation, where the passage of time is altered by the intense gravity surrounding a black hole. Now let's talk about what happens when you actually cross the event horizon. According to general relativity, once you pass this boundary, there's no turning back. Everything that falls in gets crushed into the singularity, where gravity becomes infinite, and the laws of physics as we understand them break down entirely. But quantum mechanics presents a different picture. According to quantum theory, information, whether it's matter, energy, or even light, can never truly be destroyed. It can be transformed, but not erased. So, what happens to all the information that falls into a black hole? This is one of the most perplexing questions in modern physics. And the answer could change everything we know about the universe. Scientists have been grappling with this for decades. One possible explanation is that the information doesn't get destroyed. Instead, it could be stored somewhere, perhaps on the event horizon itself. This is known as the holographic principle. Think of it like a DVD where the movie is encoded into the surface, and even if the DVD breaks, the information is still embedded on that surface. In the case of black holes, it's as if all the information about everything that has fallen in is imprinted on the surface of the event horizon. This concept is mind-boggling, but it's one of the leading theories in quantum gravity and may help us eventually reconcile the laws of general relativity with quantum mechanics. Some even speculate that the information may be encoded in the very structure of spacetime itself, beyond our current comprehension. Other theories suggest that black holes might be more than just cosmic garbage bins. They could be gateways to other universes. Some scientists propose that black holes might function as wormholes, providing a shortcut to a distant part of the universe, or even to a completely different universe altogether. Could a black hole be a tunnel through spacetime, offering a path to an alternate reality? It's a concept straight out of science fiction, but some physicists argue that it's a legitimate area of study. After all, black holes have some strange and seemingly impossible properties. Could they contain entire parallel universes? Could they provide the key to understanding other dimensions beyond our own? Stephen Hawking's groundbreaking theory of Hawking radiation also plays a critical role in our understanding of black holes. According to Hawking, black holes are not completely black. Over time, they slowly emit radiation due to quantum effects near the event horizon. This radiation, known as Hawking radiation, could eventually cause the black hole to lose mass and slowly evaporate over billions of years. But here's the catch. If the black hole evaporates, what happens to all the information inside? Does it get released back into the universe, or is it forever lost? This question has been a source of intense debate for decades. If information cannot be destroyed, then what does the evaporation of a black hole mean for the very nature of reality? One idea is that the information could be encoded into the Hawking radiation itself. This could mean that black holes might not truly destroy information, but instead, release it in a different form once the black hole evaporates. But we still don't fully understand how this would work. Is there a way to extract the information encoded in the radiation, or is it forever beyond our reach? And if black holes evaporate completely, what happens to the objects they've consumed? Does everything get returned to the universe, or do the black holes take their secrets to the grave? It's a paradox that has kept physicists up at night for decades. Could a human survive falling into a black hole? In a small black hole, the answer is simple. No, you would be destroyed. The tidal forces are so intense that they would rip your body apart before you even reach the event horizon. But in a supermassive black hole, the situation changes. Near the event horizon of a supermassive black hole, the gravitational forces are weaker, and it's possible that you might pass through the event horizon without experiencing immediate destruction. But once you're inside, there's no way to know what lies beyond. You could be traveling through a completely different part of the universe, or perhaps even another universe altogether. One theory suggests that black holes could be linked to a multi-dimensional universe. If this is true, the event horizon might act as a portal to a realm completely different from our own. The idea that black holes could connect to other dimensions, perhaps even an infinite number of universes, is a concept that has fascinated physicists for decades. If this is true, falling into a black hole could be the beginning of an incredible journey through the fabric of space and time itself. We might be looking at a multiverse, countless different realities, some similar to our own, and others radically different.